Oh, good morning, guys. Today I'm continuing in this little series that is developed from a very basic little speed test from some time ago, a video I made. It seems to be progressing and climbing, and we keep adding to it. So today I'm looking specifically at a request I got from one of your viewers, namely CodeBit, and he asked me to run a bit of code that he wrote, and he didn't specify that it must be run in .NET Core, but I assume it must be because that's what the previous test was. He gives me a link to where I could download his code and so forth, which I then did and had a look at, and it's very nice. It did make a very good speed improvement for C#. So yes, it was more optimized. Very well done, CodeBit. I like what you did there. Okay, so and he tells us here how long it took on his machine, 660 milliseconds on his almost 9-year-old PC. This one that I'm running on is also somewhere in the vicinity of 10 years old. I'm not exactly sure. I often say it's old, but I never know how old it is. It's about 10 years. And then his PC specs is an Intel i5 running at 3570. That's 23% faster than my machine, but he's got only 4 cores. Non-hyper-threaded. I'm 4 cores hyper-threaded, which is what I did the test with, was 4 cores hyper-threaded, so it's 8. Then he's got 8 gig RAM, I got 12, that should make a difference. He's running at 1600 megahertz and I'm running at 1333. So yes, so his CPU is a little bit faster, but like he said, he wants to see how this performs on my computer. So it's not a comparison between my machine and his machine, but his code on my machine versus my original code on my machine versus Rust. Okay, so this is the original code that I had. We can run it quickly. I will put links on this video so you guys can go and see the previous little comparisons we did. You might want to start from the first video. There are now with this one 4 in total. And okay, so everything is the same as what it was. We're still running a release mode, x64, forced, etc. So we'll give that a run and see how long it takes. Last time, if I remember correctly, it was 5.4 seconds. And this time 3.5. I did notice for some reason things are a little bit quicker today in this VirtualBox. But let's see. So that was 3.5, 3.7, doing very well. Give it one more try just to average things out a bit here. It's a bit slower there, definitely 4.1. So I don't know. Let's say 3.7 seconds. Okay, just for the hell of it, just quick in my head workout. All right, then. So if I collapse this function and I open up what he sent me, like I said, it does the exact same. Just a different way of doing it. He's using a generic list, etc. Same, everything is good. And yeah, so it's nice bit of optimization he did. Yeah, the one thing I did notice is that this loop over here, this range over here, you started at 1. That should be a 0. Okay, and that's the only issue I found. And even with that, I mean, we're still going to get some great results. Okay, so if we run this one instead, what did I say the other one was? I think 3.7 seconds. So let me just copy his function name out here. We'll stick it in, sorry, that's my function name. We'll take his function name and we'll call his. Okay, so remember again, it's running on 4 cores in a virtual machine. So if you run that, so it was 3.7 and his is a little bit faster here. And that's great. That's 2349. That's more or less what my test gave me as well. So it's, yeah, that's about what it is. But let's run a few of those. Okay, so let's see. That's a nice one. Just over 2 seconds. We'll do another 1 or 2. 2.1. Let's give it one more go. It looks like it might be an average of 2.1. 2.2. So no, give it one more go. 2.2. Now I'm going to say 2.1. Okay, because I'm not the brightest guy on the planet. I have forgotten what the previous times were for my bit of code there. I think it was 3.7. But yeah, let's just write these things down again like I did last time. And okay, so in the VM, code bits code gets about 2.1. All right. So CodeBit, there's already a big difference for you. As you can see, you're running on a virtual machine versus your machine. You're saying 660 milliseconds. That's quite a bit faster than what I'm getting. But it is the same code. So yes, there we see how things differ on obviously different platforms. Okay, so that's CodeBits. Then let's just say original. And I'm going to run that other code of mine quickly again, just to make sure. But like I said, I think it was 3.7. Let's quickly get back into that again. Let's undo that method call. Okay, so now it's calling the original code. .9 this time. So yeah, I was right with the 3.7, let's say. All right, so let's stick that in. That's got a performance increase there. Okay, 3.7. All right, now the actual test is that I'm supposed to, I guess, I'm supposed to be running this on Linux itself in .NET Core. So let's make sure that I put his stuff back again. So it's expensive function. Let's make sure. All right, I don't want any mistakes here, and it should be fast. Yes, 2.2. Okay, just yeah, let's say 2.1 still. Let's maybe 2.2, but let's say 2.1. That's good enough. All right. Okay. So if we go ahead and we publish this, and we publish it, okay, it's going to be put in the publish folder. Let's remember that path there, and let it start its publishing. Are you actually publishing now, man? Oh, sorry, wrong place. My mistake. Okay, so we need to copy that over to the Linux machine, and okay, so it's in here, bench core, bin x64 release netcore apps 3, and okay, so I've created a another folder here. This is on the Linux box, bench core CodeBit. Okay. So if we take this code we just generated on this side, we put it over. Okay, and it's now on the Linux machine. All right, so let's close everything down and do it nice and neatly, and do a proper shutdown. Can now shut down. Okay, I guess we can quickly go to the other screen here and just close this down. Okay, and we should be greeted with, okay, and there's the original code in Rust. Okay, and this is what we're going to compare today as well. So like I say, there's already a speed difference between the original .NET Core code and today's .NET Core code. Thanks to CodeBit, and yeah, we'll do that comparison. Let's see, it's shutting down still. Okay, gone. Okay, so let's just stick this on the same desktop. Okay, workspace 1. All right, so there we go. So okay, okay, so this is the original code. All right, that was running from the previous benchmark. Or speed test. Again, I must stop with the benchmark thing. It's not a benchmark. Just got stuck on that word here. Okay, so all right, so it's running at the original .NET Core code in a loop here, and so we can see the numbers changing there. Let me just zoom in here a little bit for everyone to see a little bit better. Zoom in. Okay, so that's 4.6 seconds, 4.8 seconds, and 4.7. Okay, so it's hovering in that area. 4.6. Okay, so I think let's stop that. Okay, and then what we can do is we can run CodeBits, and so if I remember it was just CodeBit. Okay, so I have no idea what the speed is going to be, guys. I haven't tested this. I copied it over for the first time now, so let's see what happens. So we'll also run it in a little loop. And let's see, great, 1.4 seconds there, 1.4 and a half, 1.6. Oh, that's really quick now. So we're looking at about 1.6, is a little bit slower there, 1.68, 1.7, 1.8, 1.83. So it looks like we, yeah, let's say about 1.7 seconds. Yeah, all right, let's cancel that. All right, so that's 1.7 seconds. Okay, so that's a bit of an improvement. Okay, so that is CodeBits core.NET Core 3. So what did I say? That's 1.7 seconds. Okay, and then if we go to the Rust code, this is the exact same as original. I've made no changes. Release mode, everything, that's the exact same. Okay, and if we run that, maybe we can stick that in a loop as well. Let's run it, let's say every second or so. Well, that might be too quick for us to, well, let's make it every 1.5 seconds. 1.5 seconds we'll run it. Okay. All right, so that was 151 milliseconds, 133 milliseconds, 151, 182 milliseconds. Okay, 138, 6, 48, 136, 158. I don't know, so it's kind of, it looks like it's around about 150. Yeah, I think I'll call it at that. All right, so let's stop that. Okay, and okay, so that makes that 150 milliseconds. So that's 150. Okay, so I'm going to stop the video at this moment. I'm going to reboot my machine and start it up in non-hyper-threaded. And let's see what differences we get out of that. I hope we can do it because my machine is very fidgety. It's actually a 2.8 this, and I can't start my machine. It won't start up if I'm on 2.8. I have to actually overclock it ever so slightly to 2.9. It's the only way I can get it to boot. Anything under 2.8 and anything over 2.9, it will not start up. All right, so yes, this is also an old machine. But okay, so let me stop the video at this point, do a reboot, and we'll take it from there again. All right, and we're back. Sorry, that took a few moments there. Like I said, my machine is a little bit also on the old side. It wouldn't boot up after switching off hyper-threading, but I finally got it up and running. Okay, so all right, so we still, that's the original code and everything, nothing has changed. Here's our times from just now, etc. Okay, so just to show you, I have only got my 4 cores now instead of 8. And as you can see, OBS itself, my recording software, is using up quite a bit of processing speed there. But let's see what happens. Okay, so well, let's start off with I'm already in the folder, and let's run see, I'm definitely in the bench core codebit folder. Let's just zoom in here a little bit so you can see better. All right, so and I'll make this a little bit smaller. Okay, so all right, so we're doing the exact same thing as what we did just now, and like I said, it averaged out at approximately 1.7 seconds, and CodeBit managed 660, but then I don't know what was running in the background. Oh, by the way, CodeBit did it on Windows Home. Not sure which version though, but it was on Windows Home. But anyway, and just an interesting point as well, just so I'm running on Linux, he was running on Windows. He got 660 milliseconds, I was on 1.7, but do remember my recording software is running as well. So let's run it in a loop here. We'll run it every 1.5 seconds and we'll see what sort of the average is going to be. 1 second, yeah, well, that's 1.1, that's like a 65% improvement by switching off hyper-threading. Can be expected. If you don't have too many threads running, then yeah, your threads will run much faster if you're not using hyperthreading. Yeah, so 1.1, yeah, it's sitting around about 1.1. Okay, so 117, 193, 12, 12. Okay, it looks like 1.2. All right, yeah. Okay, so I'm gonna call it at 1.2. All right, and let's just write that down. Okay, so so it's on 4 cores instead of 8. Well, hyper-threaded 8. Okay, so we get what did I say? 1.2. All right, 1.2 seconds. All right, so the Rust, so that's a performance increase already. Hyper-threading down to. Okay, and so Rust is 150 milliseconds. Let's open Rust here again. We'll do the same thing with Rust. We'll run it every 1.5 seconds, and let's see what we get on that. Okay, 145, 137, 138, 135, 868, 147, 35, 42, 39, 40, 34, slow one there, 141, 140. Okay, I think I'm going to call it at, again, under 130, let's say 138. Maybe, yeah, that's low again. 146. Okay, I'm going to say 139 milliseconds. All right, let's stop it at that. Okay, minimize that. Okay, and we got Rust. So Rust did improve ever so slightly. Not as much as what .NET Core did though. Performance difference didn't make that much of a difference. The cores didn't make that much of a difference in Rust as it did in .NET Core. All right, so let's work out some percentage improvements here. I should have shut down system monitors on its own. That could have taken some of the speed away, but all right, because that's quite intensive as well. For you Linux guys out there, have a look at Glances, command line app. As far as I know, it's written in Python. It's a nice quick way to have an overview of what's happening on your machine. I can just maybe quickly show it to you. You don't need to be sudo to run it, and it'll just give you all. It tells you, you know, how many cores you got, like it says in the top right hand here. Tells you what's happening on your CPU. So OBS itself is using 32% of my CPU. All right, so if I switch off OBS, those times that we just checked for Rust and .NET Core will definitely increase. And we can see my hard drives here. You can see the temperatures of the core, 77. Well, it's a cold day in South Africa here today. It's normally sitting at 90. But yeah, network usage, everything. So nice. This and HTOP together is quite nice utilities. But sorry, I digress. Okay, so like I say, let's work out some percentages here. All right. So the improvement. Let's see. Let's first work out, okay, in the virtual machine, the original .NET Core code versus the new .NET Core code. So that would be 3.7 divided by 2.1, and that is a 76% performance improvement. Thanks, CodeBit. 76%. That's good. That's very, very good. Okay, so let's just write that down. Okay, so equals 76%. All right. Then in Linux itself, Rust versus .NET Core. Okay, so we say 1,700 milliseconds divided by 150 milliseconds. Okay, so Rust is 11.3 times faster. Okay, so it was 1.76 times faster. Let's rather not say percentages. Well, you can say 1,000 or whatever. But so it's 1.76 times faster, and this is equals 11.3 times faster. And then when we went to quad core, purely hyper-threaded off, okay, and then we get, let's just check it again. All right, so it is 1200, okay, versus divided by 139. Where am I forgetting now? 139. Okay, so Rust is 8.6 times faster. So core caught up a bit there. So it's 8.6 times faster. And then we'll also do a hyper-threaded versus non-hyper-threaded .NET Core comparison. So that, in other words, will be our, 1.7 divided by 1.2. Okay, so that's a 41% or 42% performance increase for .NET Core hyper-threaded, okay, going to non-hyper-threaded. It is a 41% performance increase. All right, so, you know, yes, I've said this in the past, hyper-threading is not always faster. It depends on what you're doing. So, okay, so that's brilliant. 42%, let's say. 42% .NET Core versus .NET Core hyper-threaded versus non-hyper-threaded. That says a lot. Okay, so in summary, okay, so, what is that? So that, okay, so yes, so we got it up to 8.6 times faster for Rust, where it was 22 times, if I remember correctly, and then dropped to 11.3, okay, compared to .NET Core, 11 times faster. Then going from hyper-threaded to non-hyper-threaded, it's now 8.6 times faster. So it's still much faster, but again, like I always say, Rust and C# are not direct competitors. Although it's great to code in Rust, it's really nice, but C# is brilliant in its own rights. I love C#. You can watch some of my other videos as well, and you know, should you still be using C# today, for instance? And yes, you should be. But all right, okay. What I'm going to do is I'm going to stop the video now, and then I'm going to rerun these tests quickly, and I'm going to post as well what the times are when OBS, the recording software, is not running. Okay, and just see what difference that makes. All right, so yes, I'll post that at the end of this video. It'll just be an image that comes up with the speeds, all of them. I'll summarize all of this, and you can have a look at that. And yes, there we go, guys. Thanks a lot, CodeBit, and yeah, enjoy, guys. We'll chat again. See you, man. Bye.